All right, today we're going to look at equivalent expressions. So this will be a pretty short lesson. We're going to review a little bit of what you've already done and talk about what that has to do with equivalent expressions. So first let's just talk about like terms. So let's say that I have 2x plus 5y minus 8x plus 7z minus 3x plus 8y, and let's just call that good. So take a moment, write all of that down. This is a z. I put a little line through my z so it doesn't look like a 2. So get that written down. And then we're going to look at our like terms. So if we're doing like terms, remember that they have to have the same letters or have no letters at all. So 2x minus 8x and minus 3x go together. Oh, and some of us still like to draw the lines before the plus and minus sign. So let's do that really quick. And when we do that, we separate this into terms. There's 6 terms there. And that helps us figure out where these signs go. So this minus sign turns into a negative sign for the 8. This minus sign turns into a negative sign for the 3. So I can put those together. So I'd have 2 and negative 8 and negative 3. So if I put 2 and negative 8 together, that's negative 6. Negative 6 and negative 3 together make negative 9. So I'd have negative 9x. It's like I have 2 worms and then I had 2 spiders, 8 worms, and 3 worms. So that's how that comes out. Then let's see what else we've got. So I've got 5y here and 8y here. So it's not a very good highlighter. We've got 5y and 8y. They're both positive, so we can just add those together. That gives us 13y. And then poor z, there's only 7 z's there. There's nothing to combine with it, so we'll just put that on the end. This and this are considered equivalent expressions. If you do all of the math right, these are equivalent. So let's do another example. Let's say I have negative 5x plus 8 plus 2x minus 9. We'll just make it like that. So we'll draw our lines to separate the different terms here. So my x's are what we call like terms. We've done like terms before, so those go together. So I'm going to add negative 5 and 2 together. So think 5 spiders, 2 worms. I'm sorry, 5 worms and 2 spiders. So the worms would definitely win. There'd be 3 left over. So negative 3x. Let me try a different highlighter for this. Oh good, this one works. And then the numbers that don't have any x's or anything on them, those go together. So positive 8 and negative 9. This would be like 8 spiders and 9 worms. The worms would win by 1. So I'd have negative 1. So these are also considered equivalent expressions. So let's change gears a little bit. Let's talk about distribution a little bit. If I have 2 times negative 3x plus 8, and it says to simplify this, I would distribute this out, and so I'd have 2 times negative 3x plus 2 times 8, and I would get negative 6x plus 16 as my answer. This and this are considered equivalent expressions, at least if I do all of the math right. So I know what you're thinking. We've done all of this. Although I will say it's always good to review. I'm going to show you how you can check if two expressions are equivalent. So let's say that I give you something like, I'm trying to think of a good one, 5, and then in parentheses, x minus 3. And I want to know if it's equivalent. I'm going to put a question mark there. Is it equivalent to 5x plus 2? So some of you are going to look at that and you're going to distribute in your heads. Don't say anything out loud. So pretend that you had no idea how to actually distribute this. What you could do is you could check using a number. So I'm going to pick a number. We usually do not want to use 0 or 1. You usually want to use something else. So let's say I'm going to check it using 3. So let's check using 3. So what I'm going to do is I'm going to substitute 3 in for the x over here. So I'd have 5, and here I'd have 3 minus 3. And then we do our order of operations. So parentheses first, I get 0 times 5, which would give me 0. Okay? If I do the same thing over here and I put 3 in over here, I'd have 5 times 3 plus 2. Do the multiplication first. 15 plus 2 is 17. That didn't work. And what that means is the answer to this question, are they equivalent, would be no. They are not equivalent. They didn't give me the same answer when I took the number out. So let's do one, let's do something else. Let's say I have 8x squared plus 2x. And I want to know, is it equivalent to 2x times 4x plus 1? So this is a little different than the ones that we had done with our distribution property. So I'm going to pick a number. Let's check using the number 2. So I'm going to put 2 in where both of these x's are. So this is going to be 8 times 2 squared. Whenever there's a number and a letter next to each other like that, there's always a times between, so you can write that little times sign. Or you can use parentheses like we've done in the past, but I think that was confusing some people, so I'm just going to use the times sign. And then I will have plus 2 times 2. So where this x was and where that x was, I put in a 2. Okay, I don't have any parentheses. My next step would be exponents. So 2 squared is 2 times 2. That's 4. And I still have the times 8 and the plus 2 times 2. So we didn't have parentheses. We did the exponents. Next on the list is multiplication and division. So we're going to do all of the multiplication. So 8 times 4 is 32, and 2 times 2 is 4. And we can't add until the very last step. I have to do all the multiplication on the left and the multiplication on the right, and then we can add as the final answer, and we get 36. Okay, over here, I'm also going to put in 2. I have to put in the same number. So I'd have 2 times 2 out here, and then inside my parentheses, I'd have 4 times 2 plus 1. So I have to do parentheses first, and then inside the parentheses, I also have to do order of operations. So multiplication becomes before addition, so I'm going to do this first. So it'll be 8 plus 1. I still have this 2 times 2 sitting out here. And then I still have my parentheses on there because I haven't finished up what was inside. 8 plus 1 becomes 9. So now my parentheses are done. If I want to, I can take this parentheses off. I would just have 9. And that would get multiplied by the numbers out here. So now it's all multiplication. I'm just going to go from left to right. So 2 times 2 is 4. And then times 9 is 36. And if these come out the same, that means that they are equivalent expressions. That means that this and this are equivalent. So the answer to that question that we asked was yes, they are equivalent. Another way we could say this, we could say ax squared plus 2x is equivalent to 2x, 4x plus 1. So this is a way to check without using your distribution property or without combining like terms. We haven't really talked about how to distribute something when you have x's on the outside also. So even if they give you some crazy thing, you could take a number, put the same number into both of those expressions, and if they come out the same, they're equivalent. If they come out different, then they're not equivalent. Okay, so let's turn to your practice page. And so I've got equivalent expressions. This is for spring 2017. If you're watching this in a later year, the page number and the date might be different. So we're going to say tell if each pair of expressions is equivalent. And I'm going to give you a couple of these. So you're going to give me a yes, it's equivalent, or no, it's not. So on number 1, let's say that it is x squared plus 2x plus 1 is the first one. And the second one's going to be x plus 1 in parentheses and x plus 1 in parentheses. So you're going to tell me if these two are equivalent. And then for number 2, let's say that I have 5x times 2x plus 4. And you're going to tell me if that is equivalent to 20x plus 10x squared. So you're going to pick a number to put in both of these, see if they come out the same. You're going to pick a number to put in both of these to see if they're the same. Don't use 0 or 1, just because that often doesn't work. And sometimes you might want to use more than one number to check, just if you're not sure. But do that, and we'll check your answer here in a little bit.